I found the mean. Hey. Okay, so I found the mean. Then I showed you how to use the calculator to determine the standard deviation. And I explained what the standard deviation is. Okay? Now we need to move on to question 3. Okay? Now it's very important to know that the mean is our point of reference. Okay? The mean is our point of reference. Right? So the next question says, what percentage of data values are within one standard deviation of the mean? Okay? Now, from my experience, a question like this, it causes problems to some learners because of not understanding what this is all about. I'm the mean. Okay? That's 46.93. The standard deviation is 20.57. So 20.57 to my right, 20.57 to my left, that interval is called one standard deviation. Okay? If I'm the mean, and then I multiply the standard deviation by 2 and I go to my right, then by 2 I go to my left, that's 2 standard deviations. If I multiply the standard deviation by 3 and I move to my right, and then I multiply the standard deviation by 3, I move to my left, that's 3 standard deviations. So sometimes we may need to know how many values in the data set fall within one standard deviation, sometimes 2 standard deviations, sometimes 3 standard deviations. It's very easy. Okay. Right, so here, since we've got an interval, if we use interval notation, we can write that interval like this. So this is the lower limit, that is x bar minus sigma. The upper limit is x bar plus sigma. Okay, we can also write this using, we use inequalities, so that would be x bar minus sigma is less than x bar. X bar is less than x bar plus sigma. You can also write it like that. So we want to determine the percentage of values in this data set such that those values are within one standard deviation. Okay? Now, to be able to get the answer, first we need to know our mean x bar, which we got. We have got our standard deviation. So let me determine that interval. So it will be 46.93 minus 20.57. Whatever value we get here in terms of the difference, that's our lower limit of that interval, which is one standard deviation. Then the upper limit will be 46.93 minus 20.57. Okay, it will be plus now. Okay, just give me a second, I need to recalculate my code. Okay, right. What answer do you get?
22.36.
Okay, just give me a second. Determine how many values are within one standard deviation. Okay, so you go to a data set. Remember, your minimum is 26.36, the maximum is 67.5. So, the 48, we have to take it into account. It's within this interval. The 40 is there, the 65 is there, 35 yes, 42 yes, 12 no, 18 no, 102 no, and then 63 yes, 55 yes. Are you following? Can you look please? There's 43 yes, 38 yes, 27 yes, 50 yes. 68? No. Okay, 68 is a no. Then 55, 43, 8 no. 74, 35, 33, 45, 72 no. 60 no. 49, 58, 50, 30. Liar. All right. Then, now we want the percentage of data values within one standard deviation. So we count all of them, the ones that I put in ticks, then you divide by the total, you multiply by what? 100. Are you following?
Yes. Is there not possible way to do that?
No. There is no other way. That's why when you write your test, for a question like this, you won't get a very large data set. Because if it becomes too large, then we have problems identifying the data values. So normally, it should not be too large. Normally around 20 values, probably in this case there were 30. Right, so let's do the addition for the 1, 2, 3, then 4, 5, 6, 7, 8, 9. So in total there are 21 values that are within one standard deviation. So percentage of data values. So our answer to be percentage of data values within one standard deviation this will be equal to 21 divided by 30 times 100%.
70%.
Is it exact? 70%. Okay, so that will be 70%. So 70% of the values in the data set, they fall within one standard deviation. Are you following them? Okay? Then let's move on to the next one. So I've done number 3, now let's do number 4. Okay? The good thing is we've already determined now, yes, it now says how many observations are within 2 standard deviations. Now it's 2. It's no longer 1, 2 now. Okay? It's 2 standard deviations. Okay? Since it's now 2, it means our interval is going to change. We have to put a 2 here. Okay, let me just erase this. Let me fix that quick lesson. We have got 2 standard deviations. So the interval changes now. Okay? So the distance from the mean is longer now because we have got 2 standard deviations. So that interval is going to be x bar minus 2 sigma. Okay? This will be the lower limit. The upper limit is going to be x bar. It's going to be x bar. You know what? I'm not too happy with my pen. Right. Okay, let me try to fix that. I need to actually restart my computer, but I'll do it later. So, if you do calculation, this will be 46, 93 minus 2 times the standard deviation is 3,57. Okay, can you check on yourselves? Because my e-beam needs to be fixed. Just carry on and find that interval. All right. So, if you want to get the value, so this will be equal to x bar, which is 46,93 minus 2 times the standard deviation. Okay, so that's the lower limit plus 46,93 plus 2 times the standard deviation. Okay, so what will be the lower limit? 5,79 and the upper limit 88,07. Okay. Now, what does the question say? The question says, how many observations? Now, we are not calculating a percentage. It's just the number of values in the data set that are within 2 standard deviations. Okay? So, our median is 5,7. Let's just eliminate those that are outside this interval. So, if we start with the first row, we have got that 1 or 2, we don't want it. Then we put a cross there. Then the second row, we need all of them. The third row is only this 5. Okay, so in total, the number of observations, okay, will be equal to what? 22.
What happened?
Okay, so that's number 4.